Hello friends, welcome to this session. In this session, I will try to explain construction of SCR. The current handling capacity and reliable operation of SCR depends on its construction. Basically, thyristors or SCR is multi-layered semiconductor device, and the semiconductor used is always silicon. There are two basic types of construction. There is planar diffusion construction and alloy diffusion construction. So let us consider one by one. In case of planar diffusion construction, all junctions are obtained by means of diffusion techniques. We take a large N-type wafer. This wafer is diffused simultaneously on both sides by p-type material, p-type impurities, and therefore we get a structure like this. So this is n side, and on both sides simultaneously diffused with p-type impurity. So we get here, this is p-type. In this way, we get large PNP slice or PNP wafer. Then at the top or one side, it is masked with the SiO2 layer. SiO2 means silicon dioxide, and it is a best insulator, right? So this PNP slice is masked by SiO2 and windows are cut here. So in mask we keep some windows, say window 1, window 2, and so on. So by taking large slice of this PNP wafer, then it is masked, and this is on so micro level that you can have hundreds of such windows, right? So using single slice you can get hundreds of SCR. So I repeat now, inside we have, this is a N type slice, then diffused by P type impurity from both sides, then masked with the silicon dioxide layer with windows. So through window this region is exposed, and through this window we deposit N-type impurity. So here, yeah, N-type. So look at this. What we have? P-type, N-type, P-type, and at the top level we have N-type. So PN. This is how we get the 4 layer, and you get the SCR construction. Now this bigger slice or wafer, it's cut here. It is cut across this line in this plane. If I cut this slice in this plane, what will happen? In this plane you will get PN, meaning all the 4 layer and all the 3 junction come out to a single plane, and that's why this construction is called as planar diffusion construction. And then actually what I have drawn is a 3-dimensional figure, which is very difficult to draw. So usually we draw planar diffusion SCR like this. So see, it is very simple. This is, say, this is N from both side P. So this is P and P slice. Then at the top, after SiO2 layer, there is the N region. So we have P N for layer and junction J1, J2 and J3. Okay, and the pins are connected for external connections. So one pin is connected to this P region, that will work as anode, and other pin is connected to top N region, that works as cathode, right? And one more pin is connected to P region close to N, so that works as a gate, and the whole structure is mounted on a solid base, which is the best conductor of heat, and that works as a heat sink. We call it as heat sink attachment. Heat sink means it is actually a metallic body which has a larger mass, and therefore it has ability to absorb, it has ability to sink some heat energy, and it is required in power devices because when they gets heated, that heat energy has to be removed uh, to keep the temperature of this component to safe level. So this is a planar diffusion construction, and this type of SCR is used for low current applications. In the laboratory, we are using the SCR of this kind. The second important type of construction is alloy diffusion construction, or mesa type, maze. Now here the name given is alloy diffusion, means one junction is obtained by a diffusion technique, and the two junctions are obtained by means of alloying. Alloying means when two kinds of metals are joined at high temperature, it is like a welding. We call it as alloyed joint, right? So construction is very simple. Look at this. This is PN region, large P region and region, and this junction is obtained by diffusion technique. That means this is single silicon chip. Half part is doped with pentavalent impurity, which gives N type, and half is doped with trivalent impurities, that produces P region. So this junction is obtained by diffusion, and then the P region and N regions are alloyed to this. So when this P region is alloyed, we get junction J1, and this N region is alloyed, high temperature soldering, you can say, alloyed, that produces the junction J3. So we get the structure P type, N type, P type, N types. Once again, we have 4 region and 3 junction, and that constitutes the SCR. Then this whole structure is braced between two metallic plates. It can be a tungsten or molybdenum plates. Bracing means just fixing it, right? So they are braced and for the better mechanical support, and these metallic plates also allow large current through it. Then this anode plate is hard soldered to threaded stud. Threaded stud म्हणजे आट्या पाडलेला मोठा screw, that is hard soldered to this, so that with this thread you can fix this SCR to heat sink, so that heat sink will absorb the heat developed here, because this construction is used for very high current. It gets heated, and therefore this energy has to be removed to keep the temperature safe level. Then another connecting rod is connected to this cathode plate, and then one small aluminum wire is connected to P region close to cathode, that works as a gate. So this is the construction of alloy diffusion type SCR. And remember that this type of construction is used for high power handling. Hundreds and thousands of ampere current can be handled by such construction. Actually, this structure that I am showing you is a vertical section of this SCR. So these plates and total structure may have rectangular size or it may have circular size. The other name, it is also called maze type. Maze म्हणजे table सारखं structure, table, round table or square table. And why it is called maze type? Because if you consider any table, so I have one diagram here. This is a say table. In case of table, what we have the plane surface, then we have sharp edges, and then we have offset, then like this structure, like this small part and then again large part. So maybe because of that, such thing is there, the plane and then offset, again the plane and offset and plane and offset, and like that. Might be because of that it is called as measure types. So we shall stop here. Thank you.